Alrighty, guys. Good morning, good afternoon, depending on when you're watching this. Today's Wednesday, October 14th. We're going to continue on with section 2, but I am actually going to have you guys, if you're keeping up with your notes in your notebook, I'm going to have you actually add some stuff here because we're actually going to be able to look at some examples today. Everything's not strictly going to be graph related, even though there's going to be a direct correlation between the graphs you're going to see and the actual work that you're going to be doing today. So I guess for to get started, you can, if like I said, if you're keeping up with your notes in your notebook, it's the 14th. It's section 1.2. Section 1.2 is titled Analyzing Functions. So we're analyzing functions both from their graph perspective and also from their equation perspective. So we're going to talk pretty extensively about both of those concepts today. The thing that we're going to do, though, is we're going to look at some really simple concepts, and we're going to start to find kind of a deeper meaning or a deeper appreciation for what they actually are, okay? So we're going to take, to start with, we're going to take something that obviously, if I were to ask you guys to define it, every single one of you would know exactly what a y-intercept is. The thing is, you would define it all the same way. You would define it from a graphic perspective. So what I mean by that is every single person would probably take this concept, what a y-intercept is, and you'd say it's the point where something, you would probably use the word line because that's what we're most familiar with, but in reality it's the point where a graph crosses the y-axis. And you'd be absolutely right. If I were to draw something like this, and again, it doesn't have to be a line, it could be a parabola, right? It could be a parabola that does this. Parabola that's up here at 1. So technically its y-intercept is right there. And everybody would say its y-intercept is 1. 100% accurate. You're not wrong for saying that. What I want to look at, though, is I want to look at the definition that's going to help us find the y-intercept algebraically, meaning when we can't actually see the picture of the graph. So the point I want to make is this. Don't think about that as the actual number on the number line, but think about it as the ordered pair. What is that as an ordered pair? Well, it's the ordered pair 0, 1. And if you think about this, any y-intercept, if you have a line that looks like this, that has a y-intercept of -2, that y-intercept is the ordered pair 0, -2. So the way that we're going to define a y-intercept is this. We're going to say it's the y value when x is 0. But we're not going to actually use the word y value. We're going to say the function's value because, again, y and f of x or function of x are interchangeable. So here's the way that we're going to define the y-intercept. We're going to say the value of the function when x equals 0. Okay, so we're going to come back to that. We're going to look at an example. We're going to add an example to our notes here in just a second. Okay. But again, we're going to have it defined that way. Now, the other or the corollary to this, the corollary to the y-intercept is obviously the x-intercept. But what we're going to do is we're going to rename x-intercept, okay? What we're going to rename the x-intercept is we're going to rename it the 0 of a function. Okay, so just write that 0 of a function, underline it, and then in parentheses, we will identify that essentially all it is a 0 of a function is its x-intercept. Okay, and again, I'm going to give you a little picture to go off of here. You don't necessarily need either one of these pictures, but I want to just show you it. Let's say we have a parabola. Let's say we have a parabola that has an x-intercept at -1 and an x-intercept at +3. So maybe it looks something like this. It looks like that. It looks like that. It's got an x-intercept at -1 and an x-intercept at +3. We would say the x-intercepts, there are two of them. So we could say our x-intercept equals -1 and +3. But in reality, the way that we're going to do this today is we're going to say the zeros of the function are -1 and positive 3. And here's why we call them the zeros of the function. If you think about this from an ordered pair perspective, this is the ordered pair -1, 0. This is the ordered pair 3, 0. Make sure you guys can see that. Yep, you're good. All right. They're the numbers. The zeros of a function are the numbers that go along with or have a corresponding y value of 0. But if you're going to say that the y value is 0, another way of saying that is it's the function's value is 0. So again, the zero of a function gets its name from the fact that it's the point where the y value is 0. Well, obviously everybody knows that a point with a y value of 0 is a point on the x-axis, and we're more familiar calling that the x-intercept. But again, these are considered the zeros of the function. So we're going to say the values, I should say the value of x when y, which is f of x, is 0. So y or f of x equals 0. So when a function's value is 0, its x value is what we call the 0 of the function, or the x-intercept. Okay? So here's our example that we're going to look at. We're only going to put probably 2 of them in our notes here because I'm going to be forced to kind of bounce back and forth between this and page 16, the picture or the example on page 16 in your notes, okay? Or in your book, I should say. So here's the direction. It's going to say, find the y-intercepts, find the y-intercept and zeros both graphically and algebraically. Okay, and I'll explain those directions in just a hot second here. I'll show you what your actual homework is going to look like here. But before I do that, I'm going to give you what your first example is going to look at. It says, find the y-intercept and the zeros both graphically and algebraically. So here's the first one that we're going to work with. Let's go with this. F of x equals the square root of 4x plus 1. And that might be just a little bit intimidating to you guys at first glance. But here's what I want to show you. This is not the way the information is going to be presented on your assignment. Instead, it's going to look like this. It's going to give you a graph to go along with. But what you'll notice here is they actually give you the function as well. Now they replaced the f of x with h of t. H of t is the square root of 4t plus 1, but it's the same thing. We've got f of x equals 4x plus 1. Now, what I want you guys to see here is this. You're going to approximate, and really you don't need to write this as two separate answers. It says use the graph of each function to approximate its zeros. It also is going to say to approximate its y-intercept, but then it's going to say then find the zeros and the y-intercepts algebraically. So the nice part about this, you guys, is you kind of know what the answer is going to be before you even get started. We can see the y-intercept on this graph. We can see that the graph crosses the y-axis at 1. So it certainly appears as though the y-intercept is 1 on that picture. Now, here's the weird part. The zeros are the x-intercepts. The x-intercept on this graph is somewhere between 0 and -1. And I'm not sure how well you guys can see that, but I'm going to erase my dots here just so you can see this line crosses the x-axis or touches the x-axis just a little bit to the left of 0. So my 0 here, or my x-intercept, is somewhere just a little bit to the left of 0. So it's negative some fraction, okay? And again, the nice part is you get to see the picture before you have to do the work, okay? So you can see that your y-intercept certainly appears to be +1, and your x-intercept, which is your 0, appears to be a really small negative fraction. Now, here's how we're going to do this algebraically, okay? Again, to find the y-intercept, it's the value of the function when x is 0. All you have to do to find the y-intercept okay, is find the value of the function when x is 0. So by simply plugging in 0 for the x value, when you find the function's value, that will give you the y-intercept. So your y-intercept in this case is just simply the square root of 4 times 0 plus 1. Well, obviously 4 times 0 is 0. 0 plus 1 is 1. It's the square root of 1. What is the square root of 1? It is obviously positive or negative 1. We know, though, that I don't need negative 1. How do I know that? Well, again, I had the picture to start with. We already said right out of the gate, it certainly appeared as though the y-intercept was right there at positive 1. Okay? So again, the nice part about today's assignment is you get the picture to reference as you do your work algebraically. This is how you find the y-intercept algebraically. Now, how do we find the zeros algebraically? Well, think about it. To find the zero of a function, it is the value of x when the function's value is 0, meaning y is 0. So, to find the y-intercept, we plug in 0 for x. To find the x-intercept, or the 0, we simply plug in 0 for y or f of x. So when I take this function and I plug in 0 for f of x, if I am able to successfully solve for the x value, I will have the 0 of the function. So think about this. How do we solve for x here? Well, how do you get rid of that great big square root? You square both sides. Fortunately for us, the 0 squared is still 0. Over here, you've got 4x plus 1. All we have to do now is subtract 1 from both sides. We get negative 1 equals 4x. Divide by 4, you get negative 1/4 equals x. And again, the value of x, when you plug in 0, is what is called the 0 of the function. So we're going to say our 0 is negative 1/4. Okay, and again, look at this. We saw it here. We said our 0 is negative a fraction because it's just a little bit to the left. Okay, so another way that you could write this is you could say my 0 is x equals negative 1/4. You can write it either way. You could just say the 0 is negative 1/4, or you could say the 0 is x equals negative 1/4. At any rate, it's the same concept. Okay? This is all you're doing on today's assignment, is you're looking at a picture to find what you think the y-intercept and the 0 to be, and then you're using these two incredibly simple methods of just plugging in zeros and solving for the other variable to actually solve algebraically. So let me show you another picture here. Okay, this is the other part of the example on example number 4. You see this S curve. And again, I don't know how well you guys can see this on here, but if you have your books, you can open to page 16. And when I start looking at this, if I just am looking right away at the y-intercept, here's the y-axis. This S curve appears to cross perfectly at the origin, which means the y-intercept appears to be 0. The x-intercept, there are more than one. Not only if it crosses at the origin does it have a y-intercept of 0, it also has an x-intercept of 0. But if you can see this, and I know it's very hard to see, there are two other intercepts. It appears to be two other x-intercepts. It appears as though one of them is nice. One of them looks like it's exactly at 2. The other one looks like it's maybe 1.5, somewhere in between 1 and 2. So we're going to just say, all right, there's only one y-intercept because it only crosses the y-axis once, but it crosses the x-axis 3 times. 0, maybe 1.5, and maybe 2. We're going to use the algebraic methods to either verify, confirm, or show what the actual accurate answers are. So again, here's the example, number 2. The function that it gives us is f of x equals 3x cubed minus 10x squared plus 8x. Okay, so it gives you that function right here. This is the function that it gives you. Your homework's going to do the same thing. It's going to give you the picture and the function. Okay, so again, how do we find the y-intercept? It's the value of the function when x is 0. So it's the function's value, it's f of x's value when x is 0. So all those x's become zeros. When you plug in all those zeros for x's, you're not just finding the function's value, you're finding the function's y-intercept. Well, obviously 0 wipes out all three of those terms. 0 minus 0 plus 0 is just 0. Finding the y-intercept algebraically is incredibly easy because you just plug in 0 for x's. So we've verified that our y-intercept was right. The y-intercept is 0. Now we need to check for the x-intercepts, which again, those are called the zeros of the function. So to find the 0 of a function is to find the x value when you replace f of x or y with 0. So here it is. 0 equals 3x cubed minus 10x squared plus 8x. To solve for x here, we're going to have to do some factoring. Okay, you guys? Here's the first thing that we're going to do. We're going to undistribute an x from all three of those terms. It becomes 3x squared minus 10x plus 8. Okay? So here's the first thing I want to point out. This is now a zero product property. Okay? It's x times the quadratic 3x squared minus 10x plus 8 equals 0. The only way this is possible is if either this polynomial or this x is 0. So by just using the zero product property, we find one of our zeros. X equals 0 is one of them. And that checks that one off. We said just appeared to be 0 appeared to be one of them. Well, just by factoring this x off, since each one of those terms had one, we get one of our answers. Now, this is where that initial chapter 0 comes into play. What we're left with right here is a quadratic, 3x squared minus 10x plus 8. There are a couple different methods we can try here. One of them always works. What we could try to do is we could try and factor this by grouping, okay? Or for any quadratic, we can find its x values by doing the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. I prefer to use quadratic formula because it's the only way that guarantees I'm not going to waste my time. Quadratic formula always works. So to find our other x values besides 0, let's plug this in. Negative b becomes positive 10. Okay, the opposite of negative 10 is positive 10. Plus or minus the square root. B squared is negative 10 squared, which is positive 100. Minus 4 times 3 is 12 times C. So 12 times 8 is 96. All over 2 times my lead coefficient, which was 3. 2 times 3. Watch what happens when we clean up this fraction, you guys. This becomes 10 plus or minus. 100 minus 96 is 4. The square root of 4 is 2. So it's 10 plus or minus 2 over 6. When I split these apart, 10 plus 2 is 12. 12 divided by 6 is 2. Remember how in our initial picture we said it looked like 2 was a nice x-intercept? Well, it ends up being the case. We use the quadratic formula to find it. Now our other one we said was maybe 1.5. Let's check that. 10 minus 2 is 8. 8 over 6 simplifies to 4 over 3. So 4/3 simplifies to 1 1/3. We were close. It's not actually 1.5, it's 1 1/3 for our other x-intercept, okay, our other 0 value. So the work that you're going to be doing is relatively standard today. You're going to be looking at a picture and trying to decipher x-intercepts and y-intercepts. You're not going to call the x-intercepts x-intercepts, you're going to call them the zeros of the function, okay? But the work that you're going to do is relatively simple. To find the y-intercept, you plug in 0 for all the x's. And then it's always a little bit harder to find the x-intercepts because you plug in 0 for the f of x, but then you need to solve in reverse to figure out what your x values are. Those are the values of your zeros. Okay? So we're just continuing to analyze graphs, and now we're starting to like verify or justify things algebraically as well. Okay, guys? So you guys are doing a nice job asking questions when they come up. Just keep doing that. Make sure you stay on top of things. I'm sure you guys have all heard by now that not only this week are we remotely learning, but next week we'll be doing the same. So we're going to be, for the foreseeable future here, we're going to be learning online. All right. So you guys got to really work on your communication skills, asking questions when you have them, and making sure that you keep on top of your daily work. All right, guys? So that will do it for today. Let me know as the day goes on and as you get to your homework what kind of questions you do have. All right? All right, guys. Have a great day. I will talk to you later.